stock assessment researcher. The second level that you should get is here, the population dynamics. In fish population dynamics, we will study more focusedly on the change of the population or the dynamic of that particular population. For example, which parameter they are for the growth, or which parameter they have for the mortality, and how they have this some kind of the behavior, like how they migrate from the area or outside the area, and also some part of the stock identification. For example, at here you will learn about how to get the growth parameter properly. You will learn about how to define the mortality of the fish, and if you have enough information, or your fish show very good sign of the some hard part, so you can even try to determine the age of the fish. Right here, for example, in here, this is my project conduct with the local university to define the age of the sport fish, which we get from the Indian Ocean. Here, so you can see this is the part of the ear bone we call otolith part, which we can find in annual ring here. And here is another project. We try to evaluate and define the age of the shark from the from the spinal bone here. And if you succeed in this level, you can have the skill to account how fish can grow, how fish can die, and how they can migrate it, and you can identify the stock that part which stock we live in which particular area or something like that. If you can achieve this level, so you can reach to the next level. And this is the practical experience or practical information on the fish population dynamic. This is the case study from Gulf of Thailand in Thailand. This project is conducted to know the population dynamics of this mackerel. This is one of the very famous fish in Thailand. Every household know and really love to eat it. This project conducted for 20 years, and they do in both landing and onboard survey. And in here, they also even get the DNA information and several new methods. For example, like the real-time closure system, which one of my Japanese friends used to work with this kind of the project. Also the genetic and some small stock assessment and population dynamics here. So basically now we have very large information of this fish, of this mackerel in the Southeast Asia, and we are really happy to share with the other countries to try to conduct the similar project as here. And if you can get that two level, fish biology and population dynamics, so you can reach to the last level, stock assessment. At here, you will learn a lot of the how you can analyze the information, and some of them cooperate with a lot of the statistical method, which at first they will look very scary. But if you can become more familiar with it, so you can see what you can do with this kind of very powerful tool. For example, like you can do the CPU standardization, you can make the virtual population analysis, you can make some the production model, like, and which this production model you also can try to think that they have so many of the steps, or so many of the different model you can apply with the different situations. So what is the model level in stock assessment? From my experience that I working with the model, I can divide them into two kinds of the models. First is the cash and effort standardization. From here, you have the cash, you have the effort, so you can make the CPV of cash per unit effort. At here, you can define the trend of the cash of each particular species by using this kind of the statistical model, like the linear model, log linear model, or the general, which now we usually use this kind of the model, especially GLM, to define the trend of the cash. And we can define that that trend is increasing or declining, what kind of the management you should conduct with them. And the next is the stock assessment model, which they have two major components. First is the biological data, like the exploitation rate. This is apart from the population dynamic part, virtual population analysis, yield per recruit analysis, and spawning per recruit analysis, and so on. And the next is the fishery data, like you have the cash only data, that's fine. We can have the stock reduction analysis to define the stock status, which now this kind of the model is applied in the online platform of FAO already for you to roughly estimate your fish stock status. The next is the cache and CPUE, which we use with the production model like the Fox and Shaffer that I already explained roughly. And if you have very well information collected, you can have a lot of the parameter like the cache CPUE, including some code biological parameter and environmental parameter. So you can use very complicated model like the this SS3 is corporate like the more ecological model. So you can see and define how they are related to the other feedstock in the nearby area and how the effect will have if you catch too much of this feedstock. First, this is the CPU standardization. So at here, I try to apply. For example, this is the data I got from the safety project on Shark and Ray project. I found that this kind of information from Indonesia is very suitable for try on this kind of the CPU standardization menu model. Sorry. And because of in the project we collect the shark and whale information from many countries in Southeast Asia, but however in Indonesia, because you have the major gear as the long line of percent, which very well data collected, so it's very appropriate. At here, the model I use is the CPUE with the constant will vary with the month, monsoon season, and coordinate of the fishing vessel. So after I do the CPE standardization using the generalized linear model, so this is the final trend of the catch of the two pelagic treasure or the treasure shark in Indonesia, pelagic treasure and the big eyes treasure here. The result usually they will show that which in which time period that the cash is declining and which time period that the cash is increasing. However, this information still cannot properly use because of they are monthly information, not the annual information. So, which means in each month they have a lot of the uncertainties or error that can be occur and not be accounted in this model. So this is just the very roughly example. But I have another example for in the real case use. This is the case from the Kawa from one of the CISTEC project. We conducted the standardization to see which year that the cash is very high amount and which year that the cash is declined. So here we can define that from year 2005 until 2010, the cash of Kawa is declining, which may be reflected by the true stock status or by the some kind of management policies. So they leave us a hint to do the proper future management. So this is how we define and use this kind of standardization from CPU itself. Another case study is from the biological model. This case I use the virtual population analysis, which estimate the catch, the number of the fish in the sea, the biomass, and fishing mortality at each particular age. The calculation from the current year to the year is kind of the back calculation. We calculate from the current year situation and we trace back to the beginning of the time when this fish just recruit into the fishing crop. So they can provide the trend of the stock at each particular age. So this is the beginning information. We have catch in number of the fish. This is one of the particular fish. I got this information from Japan fisheries. They have 5 age of the fish from age 3, 6 age of the fish from age 3 until age 8. from 1985 until 1990 until near 2000s. So from this cache amount information, we can got the number of the fish left in the sea, the fishing mortality at each age, and from here we can define and evaluate the biomass of the fish. So from this kind of the table, it may look more complicated. So in the end, we will show by this kind of the graph. For example, this is the graph of the number of the fish in the sea from each particular age. We can see that the young age has the highest composition, following by the slightly older, and the oldest age is have the lowest composition. So, and this is another case study I got from my master thesis. I'm working on the sea cucumber or the gamak. So at here we can see that I observe from not just only using the age, but also using the length of the sea cucumber in millimeters. So we can see that the composition of each part of each biomass or population size of the sea cucumber together with the each parameter. For example, the purple one is the number of the national mortality. The yellow box here is the number of the catch, and the red line here is the fishing mortality of the sea cucumber. So from here we can define which size or which part of the stock that they got the very heavy fishing exploitation. So which part of the stock that we should focus to management. And the next is this is my PhD thesis. I use the yield per recruit and spawning per recruit to account the yield and biomass of the shark and ray in Southeast Asia. So this is the equation they use, and the last result they will provide this kind of the control line for the age, for each age at for capture and each fishing mortality here. It will be a little bit complicated sometimes, so I decide to cut it in the at each specific age at first capture or TC, so we can see the yield per recruit here and the fishing mortality here in comparison, same as the spawning per recruit here as well. Okay, so the yield per recruit here is the combination of the fishing and biological information. You can see that I have the this is the part of the biological information, the maximum average weight, including some of the growth rate or something like that, incorporate with the age of the fish here and the mortality estimation. The result that we can get this kind of the curve at each particular age. And the curve will provide the peak, which this peak is the proxy to the FMSY. So we call the Fmax. And somehow, if we cannot find the proper of this kind of the peak, so we can find another another reference point from the 10% of the slope over here. We call F0.1. So they use as the limit and target reference point. Limit is the reference point that if we reach this point, they will violate the biological reference point. So if the limit reference point is violated, the fish stock will be collapsed. And the next is the target reference point, which means this reference point is more like precaution. We use it to just make the caution that if we use the exploit fish stock over than this point, so that fish stock should be very carefully managed to avoid them to reach to the Fmax and over this point. So this is how we use this kind of the target and limit reference point together. And also this is the spawning per recruit analysis, which mostly they will focus only on female because only female can make the spawning, can provide the egg. They have two situations based on the comparison between TC age at first capture compared with the age at first maturity. So if the TC smaller than age at first maturity, we use this. And in the case that we catch the fish older than the age at first maturity, so we use this equation. So in the end of the result, we will get this kind of the curve. The reference point we will get that the fishing mortality that provide any percentage of the spawning stock live in the sea. For example, if 30%, which means we leave the 30% of the spawning stock survive in the sea. If 20% here, it means we leave the fish, the spawning stock just only 20% survive in the sea, something like that. So this is the category of the management. The case study on the bamboo shark here provide that for the Euphoric YPR point of view, the situation is here, the peak of the curve is here, and this is the F0.1 here, which means that, okay, for the Euphoric analysis, this fish stock is in the middle between target and limit reference point. They are still in the healthy situation, but however, we should uh, management this species more carefully and avoid them to reach to this point or far over. And for the spawning per recruit, which focus on the female, we found that the recent situation they just only we have only 20 female left in the sea. And for the sharks way, if the female just only 20% left in the sea, is not that good situation. So we should make some do something to increase this point from here to here, at least 30% left in the sea. And from the control line that they provide, usually for YPR SPR, we will overlap that two control line together, and we can make the final decision of this fish stock. At here, the green area defined as the safe zone for fish stock. And our current situation, okay, so here, this is very safe zone for the fish stock. This is good for the spawning recruit, but not good for you recruit. And here is good for you recruit, but not for spawning recruit. And here is not good for anyone. Where is our fish stock currently here? Okay, now our shark is here, which means that we should conduct some management to make sure that they will go to the green zone as soon as possible. And the next is the production model Shaffer and Fox. This is one of the very famous stock assessment model used currently. And now we introduce you the new, not new, but the kind of the software that can help you to come up with this model more easier. Okay, at first we have the Shaffer equation here, which you can see that this is the yield, this is fishing effort. And this they define that the relationship between this yield per effort is directly has the linear relationship with this fishing effort. And for the Fox model, it's slightly different since the yield and effort has the exponential relationship with the fishing effort itself. So this model, that's why this model have described the slightly different fishing situations in this kind of the curve. And together with this additional equation, for example, to define what kind of the fishing situation we are, or the K, this K is the carrying capacity, how many of the fish that ecosystem can handle. So from here, we have, this is the case study from this Paris Ray Graben in Thailand, from the southern part of the Thailand. I try to extract the data from 1986 to 2015, but however, this is a kind of the simulation study. So the result of this may not true. And this is the software we use. We call them as the ASPIC, or a stock surplus production model incorporated with the covariance with some risk assessment. So we use this kind of the software in computer program, make them do the simulation for us and get the final result. And this is the result of the ASPIC using the Fox and Shaffer model. So we can see that in the recent year 2015, our Paris stock is here. The green indicate that this is very, very safe zone. And if they go to the red zone, this is the overfish area, which is very dangerous situation. So the result indicated that our red stock still in very, very safe zone. Even in 95% of the confidence interval here, still in the green zone here. And how about the risk assessment? This is the risk assessment from the current catch compared to the MSY level. This risk assessment used to observe the total biomass or TB of the stingray here. The situation shows that at the current catch in the in the black dash line here, the catch of this species still in very safe situation until year 2020 that the catch will reach to the medium low of the risk to be overfishing here. So, and another is from the fishing mortality point of view here. The current catch still in very good condition until around year 2024, which they will start to reach to the medium low risk for overfishing here. So far, this ray is still in the very safe situation, and we should prepare some management measure for the future that they will reach to the some risk of the overfishing. Okay, and this is the summary that I already talked. But however, this is the a kind of the final result that we can get from this surplus production model, especially from this kind of the software, which can help the fishery policy maker work very more easier and smoothly to define that which stuff we should concern, which stuff we should just let them go or something like that. So wrap up. The stock assessments aim to control only one controllable factor, which is the fishing activities, together with the other biological and environmental information, so we can make the good decision. The three levels to achieve the fish stock assessment. First, you should have the knowledge on fishery biologies. Next, you should understand the population dynamics. So in the last, you can achieve the fish stock assessment. And if you gain more experience, so you can be very master in this field. They have various models and methods used in different situations. For example, if you have your data is quite poor, but you can find some biological information, so you can use YPR and SPR. But if you have very good quality of the data, so for example, like the CPUE, so you can use the Fox and Shaffer model. And if you have very good information that collect for a very long time and very precisely, you can just use the CPUE standardization, which you can observe the trend and make the policies very fast. Which the CPU standardization, I forget to mention that they are actually used in Australian fishery for some kind of the trap or long line fisheries. However, the most important thing is the data collection for the fish stock assessment and the other population dynamic and fishery biologies. In conclusion, the stock assessment is therefore this is a kind of like integrated subject. So you should it will take a little bit difficult always if you have only one kind of the knowledge. For example, like only the statistical knowledge or only the stock assessment knowledge. You should try to have more knowledge on the other fields like the biological or sometimes like the economic or even some socio-ecological, economical of the fishing community themselves to make the good decision which fish stock you should continue study, which kind of the management you should propose to the policymaker or something like that. So it requires a lot of the knowledge and understanding from very kind of field. And there are no absolute answer for the stock assessment. So every skills and experience required because right in the stock assessment the result we have got is not absolutely right. Sometimes they also include some uncertainty which we should account on this. And if we have enough of the experience or information, so we can make the right decision or the right result. And it takes time, but if it's in the right hands, so it can make a difference of our food future of the food supply issue for the and also the better fishery and environmental management. So I would like to end my presentation here, And thank you so much for your attention and patient listen to me. Okay.
Okay, thank you very much. What a very great presentation, Kansang. So now I invite for maybe 5 minutes more.
Okay.
I invite maybe is there any student that want to ask something or making comments on the presentation? Maybe you are welcome to say it by raise your hand with the feature of raise hand. Is there any question?
Any question is very welcome. For
Yeah,
example,
yeah.
even just how you live in Japan is also okay.
Okay.
Saya takut pakai bahasa Inggris.
Okay, is there any question? Maybe.
I don't.
Excuse me.
Yes.
Yeah, sure. Lutvia, yeah.
Good morning, Dr. Supapong. I want to ask Dr. Supapong, for tropical fisheries, we should use Scaffer model or Fox model. Thank you.
Okay. Thank you so much. This is a good question. At first, when we study, I'm not sure in Indonesia, but in my master course, usually the concept that we for the tropical fish we should use the Fox model since they are more reflected to the real situations. But however, from my experience, even in the tropical area, some of the fish species still have some activities similar that more fit better fit to the Shaffer model. For example, like some very high migratory species, like for example, like some tuna or some sharks, or even some land species with the river condition will change depend on the season. So I think for the tropical is both of the model can be used. However, the key point is if we can get the result, we should compare both results together and define that which model is better fit for this that fish stock. For example, we can define from because Fogg and Schaeffer use the history cache data, right? So our result from Fogg and Schaeffer that we calculate also will provide that kind of the history cache information. So if we can compare which Fogg or Schaeffer result, which one is more closer to the cache history of that species, so we can use that to justify that which model we should use. For example, in the aspect model that I already present, they will calculate both Fogg and Schaeffer together. And then in the final, they will show that which model has the better fit to the our data. And we can consider use that kind of information. Yes.
Okay, yeah. Thank you for the answer. And actually, can there is some question I collected and also including my personal question about the model itself. But
Yes.
I think we will list that and then send you by email for the questions left, and then maybe you can answer for the next meeting, and then next meeting will be about of practical, right?
Yes.
Practical. Can you share roughly what will be about?
Okay. So the next meeting will be
Selesai.
the practical from my experience that when I work with the stock assessment project or when I work with some information or data, which model I use or and how can I interpret the result, something like that.
Okay, and do we have to prepare something? For example, my student should prepare laptop or something like that. Do we have to? Or no? Not necessary.
It's not necessary.
Oh, okay. Yeah. This is the end of this lecture today. I'm sorry for the if there's mistake or misunderstanding about this lecture. And thank you again for Dr. Supapong to share his lecture to us, and also for student, don't forget to do presency, yeah. And because this is already 15 minutes late, so yeah, I will end this meeting and then see you again for the next meeting of 3-in-1 program, and see you. Bye bye. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Waalaikumsalam.
wabarakatuh. Yeah, thank you very much.
Okay, thank you so much everyone. Yes, terima kasih.
Enak-enak lah, enak-enak lah. Kita nggak mau foto.